Hi everyone, I hope you had a wonderful break and are ready to get started. Prior to starting this video, you should have completed the table and the graph for both Mac and Tolly's road trip and Spend or Save. Also, to complete these notes, you need this page over solving systems by graphing and tables. So those are the three things you need prior to starting this video. I'm going to start with this graph, Mac and Tolly's road trip. So as you can see, we talked about how red car, and it's Mr. Mac, he was driving in his red car and he started 50 miles away from his home. So we can see the start on the y-axis over here at 50, and it was traveling 30 miles per hour. So every hour he gained 30 miles. So you can see my graph is moving up 30 every time we move over 1 hour. Then there's the blue car. He started 10 miles away from his home here on the y-axis, and he was traveling a little bit faster at 40 miles per hour. So that meant his line was a little bit steeper, and every time he moved 40 miles, it was 1 hour. Okay? Or if we said we moved 1 hour, we went 40 miles. Now, the next step is to write an equation. So remember, to write an equation for a graph, the formula is y equals mx plus b. So on this graph, we need to decide, they want us to use m for miles and h for hours. So to figure out which letter to put here, I'm going to look on the y-axis. So what unit is on the y-axis? Miles. So y is going to be miles, and then x is going to be hours, because that's what's on the x-axis. Okay, so we're going to say m equals, let's do red car in red. You can use your highlighter if you want. M equals, now this little m here is meant to be the rate or the slope, right? This is our rate. So what was the rate that the red car was traveling? Well, he was traveling at 30 miles per hour. That was his rate. So we're going to say 30x. Whoops, we're not using x, we're supposed to be using h, right? So 30h plus, and then b is where the car begins, right? So where did the car begin? At 0, he began at 50 miles. So we say plus 50. Alright, so the rate was 30 miles per hour, and he started 50 miles from his home. You write the equation for the blue car. Alright, so it's m equals, and the speed was 40 miles per hour, so it's 40 times h plus, and he started 10 miles from his home, so plus 10. Okay? Alright, so who's going to get to LA first, and how do you know? Well, looking at my line, I can see that the blue car gets ahead of the red car as far as miles are concerned, right? So the blue car is going to make it to LA first. By the way, I just got done in LA, and it was crazy there. We went to Disneyland, and we had a lot of fun. We also saw the Rose Parade and the Rose Bowl. Alright, so the blue car is going to get to LA first. Because the line is steeper. And I'm going to put because like that. Line is steeper. Okay, the blue car gets to LA first because the line is steeper. When will their cars be next to each other on the highway? And how can you tell? Well, when cars are next to each other, that means they're the same number of miles away, right? So if I look on my graph, or if I look on my table, the cars are going to be next to each other when they have the same number of miles. So I'm looking here on my table, and I see at 170 miles, that's 4 hours. So this is our point where they're together. So the cars will be next to each other after 4 hours. So we'll say at 4 hours, they are both 170 miles. Okay? And then it says about how far from San Jose will they be when they meet? Well, San Jose is when they started, right? So we're going to say they're 170 miles away. We call this point right here a solution, okay? We call this point a solution. And it's a solution, and that solution is 4, 170. It's an ordered pair. And so what we're going to talk about today are solutions to systems. And we'll talk more about systems in a little bit. But we call this a system because in this system we have more than one line using the exact same variables, miles per hour. Okay? So the solution here is where the graphs intersect, and also on the table where they have the same y value. Okay? And we're going to use that later in our notes. Alright, let's look at spend or save. So on spend or save, we've got Goofus and Gallant, and they were saving and spending money, and it says Goofus got 170, so he started with 170, Gallant started with 10. But Goofus spent his money, so his money went down on the table, and Gallant made money, so his money went up on the table. So we're going to use the same idea to write our equations, y equals mx plus b, but this time what does y represent? Well, look on the y-axis, y represents the dollars, and x represents the days. Okay? Remember, m still stands for a rate, and b still stands for a start. Okay? So let's go ahead and write Goofus's equation. Goofus is going to say dollars is going to be m, so m equals, and he has, what was his rate? He was spending, right? So spending means we're going to use a negative number. So how much was he spending each day? It says he spent $15 per day. So we're going to say negative 15, and then x represents days, so that's d, plus, and we'll say he started with how much money? He started with 170. Most people don't write this equation this way. Sometimes they write it as m equals 170 minus 15d. Okay, so you could write it as negative 15d plus 170, or you can write it as 170 minus 15d, either way. Now let's talk about Gallant. Gallant, we're going to have you write the equation yourself, sorry. So go ahead and write the equation for Gallant. Okay, so you should have gotten m equals, Gallant had earned $5 per day. That's what it says up here, earning $5 per day. So we say 5 times the number of days plus, and Gallant only started with $10. So Gallant's equation is m equals 5d plus 10. So now we're going to see who has more money after 4 days. So after 4 days, who has more money? Well, looking on my table, 4 days, Goofus has more money, right? So for 4 days, Goofus has more money. What about 6 days? Who has more money after 6 days? Still, Goofus has more money. Now you can see this in both the graph and in the table. After 4 days, I would go to 4 days on my x-axis and follow it, and the red line is still above the blue line. Okay, so the dollars is still more, the red dollars are still more than the blue dollars. Same thing for 6 days, red is still above. What about 10 days? Who has more money after 10 days? Well, after 10 days, Gallant has more money. Okay, and you can tell by whose graph is higher. You can also tell by who has more money on the table. What day will they have the same exact amount of money? So probably the easiest way to find this is to look in the table. So in the table, when will they have the exact same amount of money? That's going to be after day 8. So we say day 8, they have $50. And how can you tell they have the same? Well, it's where the graph intersects. You can say that too. And remember, we call this the solution to the graph. So this solution is going to be day 8, $50. So now we have an ordered pair as our solution. Okay? Alright, so real quick, let's go ahead and do these notes. They look like they're going to be long, but they're actually pretty short. It's pretty much just 2 questions for the entire thing. So, let's take a look at them. Just put these 2 pages to the side, Mac and Tolly's Road Trip and Spend or Save. Alright, so we're talking about a system of equations, so there's some new vocabulary words. And a system of equations is just really a set of 2 or more linear equations. And then we talked about a solution as well. And a solution is just where the graphs intersect. Remember we said the solution here was where they had the same number of miles for the same number of hours, and here they had the same amount of money for the same amount of days. So it's where the 2 graphs intersect. It's an ordered pair that is common to both equations. Okay? And then finally, we have an example here where we say here's our 2 equations and the solution is this ordered pair x comma y. So, basically, we need to talk about the 3 types of solutions. So graphs, if I have 2 lines, they don't always have to intersect. So we have one solution, and that's where they have one intersection. We have no solution, and that's where the lines are parallel. And then we have infinitely many solutions, and that's when they give you 2 equations that are the same equation. They're the equation for the exact same line. Okay? We're going to skip all of this stuff down here. I just want you to notice that there's 3 ways to solve systems of equations. We've got graphing, substitution, and elimination, and we're going to talk about all of those in this unit, but just for today, we're just focusing on graphs and tables today. So that's the only one we're going to look at today. Alright, so we're going to come back to this multiple times. So, for graphing equations, you're going to write both of them in y equals form. That's step 1. Then you're going to find the slope and the y-intercept of each equation. And then you're going to graph both of the lines. And then you're going to find the point of intersection. That's exactly what we did here. Prior to answering any questions, I had you have a graph and a table. Okay? So on this worksheet here, we just don't have a context. So all we're going to do is graph it. So let's look at equation 1. It says y equals x plus 1. So what is m? Well, m is hiding right there before that x. M is 1. So m is 1. And what is b? Well, b is also 1. Okay? For the second equation, what is m? Well, m is that number hiding right there before x. So it's -1. And what is b? b is 3. So what you're going to do is you're going to graph both of these equations. I'm going to use red to represent the first equation and blue to represent the second equation. So if I begin at 1, and put a dot at 1, and I move, this is really a fraction, 1 over 1. So I'm going to move up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, down 1, back 1, down 1, back 1, down 1, back 1, down 1, back 1. And there's my line. Now you can use a ruler, or you can use the side of your calculator, whatever you need to draw this line. Remember, if I'm going too fast for you, feel free to push pause. Okay? Now we're going to graph the second equation. The second equation begins at 3. So we're going to put a dot at 3. 1, 2, 3. And this equation moves down 1 over 1. Down 1 over 1. Down 1 over 1. Now you can already see where they intersect. Okay? Alright, so remember, if you're having trouble keeping up with me, please press pause before you move on. So where is this point of intersection? Well, the point of intersection is right here. And what do we call this? We call this the solution. And our solution is going to be at where? This is 1, 2. Okay? So what this means is if I put x equals 1 and y equals 2 into these equations, they're going to come out the same. Okay? And it's going to say that they're true. Okay? So we're going to verify that the solution is true. So my first equation is y equals x plus 1. That's my first equation, right? So if y is 2, I'm going to put a 2 in here, and then x is 1, so I'm going to put a 1 in here. Does 2 equals 1 plus 1? Is that true or false? It's true. Equation 2 is y equals negative x plus 3. So I'm going to put in 2 for y and 1 for x, and see there's a negative right here, it's kind of hiding. So does 2 equal negative 1 plus 3? Well, negative 1 plus 3 is really just 3 minus 1, and that's true. 2 equals 2. So my solution to this equation is 1, 2. Okay? So a solution to equation is an ordered pair. Okay?